All right, everybody, let's talk about complex rational expressions, what they are, and how to deal with them. This is section 7.4 of your text, complex rational expressions. I think on the calendar it says complex fractions, same thing. Definition: a complex rational expression is of the form r of x divided by s of x, where either r of x, s or r of x or s of x, or both, are rational expressions themselves. That is, a complex rational expression is a fraction made up of fractions. So here's some examples, right? The numerator is a fraction. This is our little r of x, and this is our little s of x. And in this particular case, the numerator is a fraction, but the denominator, 2 plus x of the complex fraction, is just a regular polynomial. In the next example, we have the complex rational expression 1 minus 1 over x, that's the numerator, divided by the denominator 1 plus 1 over x. And what can be confusing is we're going to start saying things like the numerator of the numerator, or the denominator of the numerator, or the numerator of the denominator, or the denominator of the denominator. So watch out for that. In either case, this upper expression is r of x, and this lower expression is s of x. And then finally over here we have 1 divided by the quantity 2x over 3x minus 2. So in this case, just the denominator is a rational expression. So they come in many different forms. Our goal in this section is to reduce the complex rational expression to what we're calling a simple rational expression involving a single numerator and a single denominator. So for example, 1 plus a half divided by 3/5. I got fractions in the numerator, I got fractions in the denominator, and if you do the arithmetic correctly, you should be able to reduce it to a simple rational expression, which just has an integer value in the numerator and an integer value in the denominator. That is to say, no more fractions here and no more fractions here. So to see how these two expressions are equivalent, we must reduce the complex expression, the complex rational expression. There are two techniques that will achieve this result, and we're going to look at this first one right now. Technique number 1, direct algebraic computation. So these are the guidelines. I've got them laid out, and we're going to go through this little example that I have here. I have 2 plus 3 over x divided by 3 over x plus x over 2. And guideline number 1 says, obtain a common denominator in the numerator, r of x, and obtain a common denominator in the denominator, s of x. So we're going to treat the numerator and denominator separately here, and we're going to get a common denominator in both top and bottom. Now, it also says if you have part of the expression that's not a fraction, rewrite it as a fraction over 1. So we're going to be doing the following here. Here we go. So first off, this is 2 over 1 plus 3 over x divided by 3 over x plus x over 2. So we have rewritten one of those expressions as a fraction over 1. And now we're going to get a common denominator. This is 2 over 1 plus 3 over x in the numerator. And in the numerator, I'll do this in blue, the LCD is just x, so this one is going to need an x top and bottom. So hopefully you're well versed in the art of getting a common denominator. In the denominator of the complex rational expression, we have 3 over x plus x over 2. And in the denominator, the LCD is a little bit different. The LCD is 2x. So that's going to need a 2 top and bottom. Let me move this over just a little bit. And this one is going to need an x top and bottom. So what do we have here? Let's see. Let's move this out of the way just a little bit. And the result is then, let's go back to red here. The result is 2x plus 3 over x divided by 6 plus x squared over 2x. So there's our complex rational expression where we have obtained a common denominator in the numerator and a common denominator in the denominator. Next, we're going to rewrite our complex rational expression, r of x over s of x, in the archaic way with this division symbol. So 2x plus 3 divided by 2x all over 6 plus x squared divided by 2x is equal to 2x plus 3. Sorry, the denominator in the numerator is just an x. Sorry about that. There we go. Over x divided by 6 plus x squared over 2x. And then the next thing we're going to do is we're going to multiply by the reciprocal of s of x. So again, this is r of x, and this is s of x. So we're going to have the following. 2x plus 3 over x divided by 6 plus x squared over 2x is equal to 2x plus 3 over x times the reciprocal 2x over 6 plus x squared, right? So we are taking the reciprocal of the second fraction. Whoops. Not sure what happened there. And then finally what we're going to do is we're going to cancel common factors and simplify. So what do we have here? We have 2x plus 3 over x times 2x over 6 plus x squared. And the only common factor there is that factor of x. So we'll cancel that guy. And then we'll simplify. And we'll get 2 times 2x plus 3 over 6 plus x squared, which we could rewrite as 4x plus 6 over 6 plus x squared. And that would be our simplified rational expression. So let's take a look at some more examples in our next video using these guidelines. Again, those guidelines are: number 1, obtain a common denominator separately in the numerator and separately in the denominator of the much larger complex rational expression. And if needs be, rewrite everything as a fraction. If you got to slap something with a 1 underneath it, do that. Then rewrite it as old school division using this old school division symbol. Then you're going to invert and multiply and simplify. So that's it.